Okay, we are in a new unit, SYS-1, aka Systems 1, all right? So you say, Miss Lyons, we just finished systems. Yes, we did, but we finished the graphing section of systems. So if I look here, if we want to do a quick recall about what that is, recall, what is the solution to the system of equations? Okay, I have a system here because I have more than one equation. So I have more than one equation. I'm looking at two. That means I have a system. What is the solution? Where these bad boys cross. Okay, so here is where they cross. This is their intersection point. My solution is -1, 1, 2, 3. -1, comma 3. Okay, now, what happens when, I don't have any colors. All right, what happens when we don't have a graph? Okay, so what we're going to be talking about for like the next week or two is talking about how to solve a system of equations algebraically. Now, yes, you can always graph a system. Always, 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 always. Do exactly what we did in our last unit. But if somebody says in the question, solve the system algebraically, this is how you have to do it, okay? How could we solve this for the solution to the system without a graph? We have two ways to do it. One is screaming at you right here. It says substitution. So one is substitution. Okay. And another one is called elimination. Eliminate him. Mortal Kombat. Okay. So the steps for substitution. Here we are. We have 4 steps. 4. Okay. What are you looking for? All right. Remember when I have an equation, I have a system, I have 2 equations. They could be in y equals form. They could be x's and y's together. Doesn't matter. But when you're looking for steps for substitution, the first thing you want to do is use your eyeballs and look. And what are you looking for? Okay. What you're looking for is, ask yourself, does y equal or x equal anything already? Okay, so what does that mean? Okay, it means that if you had 2 equations, one of those equations would say y equals something, okay? Or it would say x equals something, okay? It wouldn't have x's and y's combobulated on one side. Just does x equal anything or y equal anything right up front, okay? If it does, okay, what you do is you take that equation, that y equals, and you substitute it in for y, okay? So, yes, get it? Subway, So substitute equation, and we'll say the y equals or x equals, okay, into the other equation. Okay, so what does that mean? Okay, it means that if you had y equals something already, in the second equation, it would say like 3x plus 2y, and wherever that y is, well, you already have y equals something, so you would just plug that right in. S&S, simplify and solve, get answers. At this stage in the game, when you substitute in that y value, you're going to be all in terms of one answer, so one variable. So it's going to be all x's or all y's, depending on what you're substituting in, okay? So simplify and solve just means combine like terms, okay, and solve for the variable. If you have x's and y's together, this is not going to work, okay? So it needs to all be x's or all be y's. All right, I solve. I solve for the variable. That means that now I need the other variable, because if we remember, a solution is an x comma y where they cross each other. So I would only have one variable here. So I take the variable I solved for and plug that back into the system, okay? And then you get the other variable. Okay, so plug back into original, sound like somebody was here, equation, and solve. Okay, so beautiful. That's amazing. Those are the 4 steps. Now, enough talking about it. Let's do it. Okay. Okay, first thing I look for, y equals something, x equals something. Okay, I'm looking for these already. Well, look at these. Y equals something, y equals something. Okay, well, here we go. $5 equals $5, right? If I gave you a $5 bill or 5 singles, you wouldn't care. You would say, I'll just take the $5, okay? Because they are equal to one another. A $5 bill is equal to 5 singles. So therefore, just like here, equals are equal. So I can set them equal to one another, okay? And if I set them equal to one another, okay, y equals y. Okay, and what I want you to notice here is that if you set them equal to one another, I no longer have x's or y's in my equation. It's only x's. That means I'm solving for an x value. So if I want to solve for an x, I'm going to combine like terms. That means that on this side, can I combine anything, that any more x's or any more constants? No. Can I combine any more constants, any more x's? No. Okay, so that means now I'm going to get x by itself. So I'm going to combine this. I'm going to say plus 2x plus 2x. Okay. Draw a line, go back to the beginning. Gone. 4 equals, if you have 6 x's and then I give you 2 more, you have 8 x's minus 20. Okay, now I have my x's on one side. I need to get the numbers away from it. So I'm going to cover the x because I want to leave it alone. And I want to move this 20. So plus 20, plus 20. Okay. I'm going to start left-hand side. So I get 24 equals 8x. Okay. All right. Last thing I have to do to get x by itself is divide by 8. Okay, and then your handy-dandy calculator will tell you 24 divided by 8 is 3. Okay, so I get x is 3. I am not done. This is a solution to a system. That means that I have the x value, but now I need the y value, okay, because it's an xy portion where those two intersect, okay? So what do? Well, step 3. Or 4, this is my step 3, my get answer step. Step 4 is to plug it in, okay? So I'm going to plug it in. Where am I going to plug it in? Do you think it matters? It doesn't matter, all right? But I like to keep things positive, so I'm going to put it into the bottom one because my x is going to be a positive number. So I'm going to plug this in to here. So I get y equals 6 times 3 minus 20. Okay, so I get y equals 18 minus 20. Okie dokie. So I get y equals 18 minus 20 is negative 2. So my solution is 3, negative 2. So where these two lines cross is 3, negative 2. It's always good to check yourself. So let's do a quick check over here, because if left-hand side equals right-hand side, it's good. For both of them, the system works. So I would get y is negative 2 equals negative 2 times 3 plus 4. Negative 2 equals negative 6 plus 4. Negative 2 equals negative 2. Excellent. So that works. That's true. So let's try the bottom one. So 3 equals 6 times negative 2 minus 20. What? 3? I'm insane. I've lost my mind. I switched my x's and my y's. This is my y. Negative 2 equals 18 minus 20. Negative 2 equals negative 2. Donezo. Okay, so that works. I'm not going to check it every time. I just checked it this time. Okay, just to show you that you can. I know you're not going to, so I guess it doesn't really matter. Okay, step number 2, or question number 2, example 2. I don't know. What are you looking for? You're looking for, does x equal something or y equal something already? Yeah, it does. I see right here, y equals 2x plus 1. Okay, y equals 2x plus 1. So basically what's happening here is instead of y being a number, y is an equation. But we're only going to use the expression part. So I'm now going to substitute in. Okay, so I have y equals, right? I have y equals, it's this one right here. Okay, now I'm going to substitute this in where I see the y in the second equation. So I would get 3x plus y is now 2x plus 1. And all of this is going to equal 6. Okay. And now notice what you have. I only have x's. I don't have any y's. I only have x's. Okay, so now I'm going to combine like terms. So I get 3x. If I had a 1 in front of here, this would just be plus 2x plus 1 equals 6. Combine like terms. So I have 3 x's. I'm adding 2 more. So I get 5x plus 1 equals 6. Okay, minus 1. 5x equals 6 minus 1 is 5. Divided by 5. So I get x equals 1. Okay, that's my x value. Again, it's not enough, okay? That's just the x value where these two cross. I need the y as well, okay? So this is your step 3. Your step 4 is plug in and get an answer, okay, for y. Now, if I'm looking to solve for y, do you think I want something that says y equals already or something that I have to manipulate and then get y by itself? Well, if you were thinking the first one, ding, 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 ding. Because what I'm doing here is I need to get a y value, and I want to know what y equals. So why wouldn't I just plug it into the thing that says y equals this already? Okay, so I'm going to get y equals 2x plus 1. And then this x is going to go right in for this y, or this x. So I get y equals 2 times 1 plus 1. And I get y equals 2 plus 1. So y equals 3. Okay, so these two cross at 1, 3. Solution. Coordinate pair where they cross. All right. Last one. This one is the last one. This is now you try. So this one will be question 1 in your homework. Okay, so this one right here. What are you looking for? Y equals something, x equals something. I have 3y plus 7x equals 4. Negative 6y plus y equals negative 7. I don't have that, okay? So what do I do? Okay, well, you want to know what's really nice about these is this bottom one looks really nice to solve for y because I have a leading coefficient or the number in front of y is a 1. So once I get rid of this 6x, I don't have to worry about like dividing or anything like that. So I'm going to solve this for y. So solve for y, which means I'm going to add 6x to both sides, okay? And I'm going to bring the y down, so I get y equals negative 7 plus 6x. Okay, so now let's rewrite the system. So really what we have is 3y plus 7x equals 4, and y equals negative 7 plus 6x. Okay, so now let's go back to step 1. Do I have y equals something or x equals something already? Yes, I do. I have y equals something. So that means that this is going to go in and substitute for y up here. Okay, so what does that leave me with? Well, the 3 stays outside. Now I'm substituting in this expression for y. So I get negative 7 plus 6x. Okay, and now I just write the rest of my system. So plus 7x equals 4. Okay. Now I'm in terms of only x's. That means I'm going to solve for x. And to do that, I'm going to distribute first. So I'm going to get negative 21 plus 18x. Okay. And then bring the rest on the right. Okay, I'm going to combine like terms here. So I get negative 21, 18, 19, 20, 21, 22, 23, 24, 25. So plus 25x equals 4. Okay, I'm getting x by itself. So I see a minus 21. So I'm going to add 21 to both sides. Okay, this comes down. 25x equals 25. Okay, I get to divide, and I get x equals 1. Not done. Not done. I have to plug it in because I need the x comma y. The x comma y is the solution to the system. Okay, so let's plug it in. I'm going to plug it in to this bottom one. Okay, because this one has y all by itself. And I'm going to solve it. Okay. Now, I want you to know that it is important to not plug it into your manipulated equation. All right. Only because if you manipulated this incorrectly, then not only did you do it wrong here, you're going to do it wrong there. Okay. So make sure you're plugging into your original equation. Okay. So I'm going to say negative 6x plus y equals negative 7. This is going to go in here. And I'm going to get negative 6 times 1 plus y equals negative 7. So I get negative 6 plus y equals negative 7. I'm going to say plus 6. Y equals negative 7 plus 6 is negative 1. So your solution, I ran out of room, is 1 comma negative 1. All right, that's that. Have a good day.